So now we've moved on from systems of equations to systems of inequalities. When we're asked to determine if an ordered pair is a solution to a system of inequalities, the process is essentially the same as it was with checking an ordered pair or an ordered triple if we have three unknowns, three variables. As it was with equations, the difference is that now instead of the statement being an equality, it's an inequality. Regardless, we substitute the values into both inequalities in a system, or all of the inequalities in a system, depending on how many there are. And if we end up with both true statements, then it is a solution. If we end up with either or both of them not being true, then it's not a solution. So in this problem, we're asked to determine whether the given ordered pairs, we've got two different sets, are a solution to the system x minus 5y is greater than 10 and 2x plus 3y is greater than negative 2. So again, we just substitute into both of our equations. So x minus 5y is greater than 10. So is 3 negative 1 in part A, is that a solution? Well, we substitute 3 for x minus 5, and we substitute negative 1 for y. Is that greater than 10? Well, this ends up being 3 plus 6. Is that greater than 10? Well, 9 is not greater than 10. That is false. So in this instance, we don't even need to check the second equation in our second inequality in our system, because we've already determined one of them is false. Well, if either of them are false, then we know that 3 negative 1 is not a solution. So 6 negative 3, same process. X minus 5y is greater than 10. So is 6 minus 5 times negative 3, is that greater than 10? So that ends up being 6 plus 15, and that is greater than 10. That ends up being 21, so that checks. Then we'll substitute into our second equation 2x plus 3y is greater than negative 2. So is 2 times 6 plus 3 times negative 3, is that greater than negative 2? So that's 12 minus 9. That ends up being 3, which is greater than negative 2. It's true. So the ordered pair that we were given, that's true when we substitute into both inequalities. So since it satisfies both equalities, we know 6 negative 3 is a solution to the given system of inequalities. So again, if either of the inequalities ends up being a false statement given the ordered pair when we substitute, then we know the ordered pair is not a solution. If it makes both inequalities true, then we know it is a solution.